Okay, so today I want to focus on some of the more advanced ways you can solve these things. One's going to be conjugates. I already mentioned it before, and I hope you're going to remember it. One of them is going to be, if you can factor it, you should. Very good. Do you get that that can be factored? Secant squared minus 1. Let me give you an example. If it had been x squared minus 1, couldn't you factor it into x plus 1 and x minus 1? So if it's secant squared minus 1, couldn't it be factored? Yes, it can. All right. So let's do this one together. But hint, just because you can do it doesn't mean you have to do it or that you even should do it. Okay. In this one, it's smarter to do a replacement of secant squared minus 1 with what? Tangent squared. Now, some of you are like, how do you know that tangent squared is equal to that? All right, I'm going to give you this tip. Whenever you are in the middle of a problem and you're like, I don't know what goes with that, write down any of the facts and try to manipulate it around until you figure it out. Like, what's the fact about secant squared? The one with the tan is what you seek. Dumb little saying, but it's meant to help you remember that one. Do you get that I can rearrange that one? And if I subtract 1 from both sides, do you get that I'll have tangent squared is the same as that? Do you get I can replace it with tangent squared? Okay. Go ahead and do that and finish that proof. It's almost done already. Yes?
So we're doing that on the test like that?
No. You can just instantly replace that with tangent squared because it's one of the facts just rearranged. There's my first step. Notice I didn't mess with the right side. Remember, you can only mess with one of the two sides. Generally speaking, you take the more complicated side and you simplify it down until it becomes the easier side. Just for today, KF, would you move up a seat so she doesn't sit on the floor? All right. Yes. Yes. Yes, you may. All right. So this next one, I'd ask you to show it this way. Tangent times tangent. Cancel, cancel. Everybody would agree that those steps are easy to see. Tangent squared is broken up into two tangents, and then, of course, one of them can cancel. And I should really put a 1 there when I do cancel it. Yes? I get what you're saying. Canceling them off, as long as you're showing me your work, I would have accepted this cancels with the squared and a 1 gets replaced. I would have taken that. Okay. Then I now, of course, either way, I have a 1 over tangent. And then that is right on the sheet. What is 1 over tangent? Cotangent. And then I can bring this all the way down. Remember, at the end you do that because you need to have a final statement that's identical on both sides. And I only messed with one of the two sides. And I only took one step at a time. Does that make sense? That's a basic proof. All right. Number 2 is kind of medium level. And then number 3 is pretty tough. I'm going to give you a quick reminder of some of the best problem-solving methods that you need to have like in your tool bag ready to go. I'm going to add a page here. I'd like you to do a couple of these with me. One is that you can factor things. I talked about that already, but I'll just say it since I already talked about it once. If you can factor it, you should try it. And sometimes that works. That's the secret. You definitely are going to use this a lot. That tangent is the same as what over what? Sine over cosine. So would you please actually write this one out? And I've done the first step for you here. You have to be able to make those two terms become one. What I mean is, a lot of times, this will simplify down to just one thing, like secant. So how can you have two things turn into one? If you get a common denominator. So everybody try to get a common denominator here and put it all together into a common denominator. You will need that twice on today's homework. There'll be 2 times where you'd need common denominators to be able to solve the questions. So that 1 is really 1 over 1. That's how you start. I'll pause for a second while you give it a try. You should have been able to change this to cosine over cosine. Why? Because then it's got a common denominator. And then you should have been able to say sine theta plus cosine theta all over cosine theta. Raise your hand if you had that one right. Okay, awesome. You will need that trick up your sleeve. I started with this. I ended with that. Do you get that the proof could have said that in the first place? And they don't look anything alike? Sine theta plus cosine theta all over cosine theta. Get how that doesn't at all look like that? But what does it have? This has 2 terms, C, and this only has 1 term. That tells you you need to get common denominators and add them. Whenever there's 2 terms on the left and 1 term on the right, or vice versa, there'll eventually be a spot where they have to get added into 1 term. Okay, so common denominator is a big deal, and I also told you about remember 1 minus sign? Right away you should be able to go, oh, there's this thing with sign and 1 in it. What was that one thing that had sign and 1 in it? Do you remember the official one? Yes, that's the fact about it. Can you rearrange that? What do we subtract from both sides? Yes. And then, look at that. It's a new fact that's usable. Cosine squared. Oh, so you're saying that's really just cosine squared. And then it's 1 over cosine squared. And isn't there a fact on the sheet about that? What's 1 over cosine the same as? Secant. So that thing all simplifies down to secant. All right. But what if it's not squared? Can you still just swap it out and get cosine? Well, let me ask you this. If that's true, a squared plus b squared equals c squared. Shouldn't just a plus b equal c then? Think about that for a second. A squared plus b squared equals c squared, but does a plus b equal c? Let's do that on a triangle. Wait a minute, the 3, 4, 5 is a classic triangle, right? A squared plus b squared equals c squared, but does a plus b equal c? No. So, I cannot just replace that with cosine. Do you get what I'm saying? But I could multiply it by, it starts with a C. Anybody know the word? Conjugate. Everybody please multiply this by, who knows the conjugate of 1 minus sign? Yes? 1 plus sign. Good. Everybody do that. That's the conjugate. You just have to change the sign. That's all you got to do. Change it to the opposite sign. Why is there some magic to that? Because the bottom turns into 1 minus sine squared. Where have you ever seen that before? What's minus sine squared actually equal to? Cosine squared. All right, now this one didn't work out particularly beautifully or anything, but I'm just trying to remind you that conjugates, when you multiply by the conjugate, you have to do it on the top and the bottom ends up becoming something that can be factored. You could factor that into 1 plus sign and 1 minus sign if you wanted, which was what we had there, which is really easy to make things cancel. Also, you can replace this with something like cosine squared. All right, now I need you to actually go and do another problem. As I said before, this is kind of like a medium level problem right there, number 2. Everybody try that one by yourself. I don't think you're going to need somebody's help. You should be able to prove number 2. I gave you a bunch of strategies. Does this look like a conjugate situation? No, I don't see a 1 plus something or a 1 minus something. Does this look like it could be a common denominator situation? Actually, it could be, but that would be a really long, slow way to do it. Does this look like it could be a change everything to sines and cosines? No, it already is all in cosines and cosines. Does this look like, this is what I would do if I were you. Go through all of these things. Does this look like an opportunity that if you can factor it, you should? Aha! Now right there, some people say, but I divided both sides by 4. Can't do that. Remember how you can only mess with one of the 2 sides. You can't just divide both sides by 4, but you can factor out of 4. All right, I'm going to actually just remove this panel, which has the answer behind it here. So you factor out the 4, and then it's 4 times 1 is equal to 4. 4 equals 4. Yay, proved. Raise your hand if you had that one right. Okay, awesome. This next one, you're going to have to pull out either change everything to sines and cosines. If you can factor it, you should. Use common denominators or use conjugates. Or maybe some combination of those. You also have to remember that you can always use reciprocals, which are like sine is 1 over cosecant. You can also use quotients, which is like tangent is sine over cosine. Oh, there's so many things you could do. Which side should you start on? The more complicated one. Everybody manipulate the left side until it becomes equal to the right side. Pausing while I put kids into small groups. So for today, I just assigned 107 and 116 and 115. I am going to take a second and go and explain how to do the one that we ended on, which was this one, number 3. Yeah, have a good day. So this, first thing they did was replace tangent with sine over cosine. Then they replaced cotangent with cosine over sine. Then they multiplied them out and distributed them, and they got this red writing right here. Then they went and got a common denominator. So the common denominator would cause them to have a denominator of sine. That's why we have that here. And this became sine squared, and this became cosine squared. And then sine squared plus cosine squared is really 1. And then 1 over sine is cosecant. All right, so that one, that's how you solve that one.